Today we can see we are going to go for students. Today we are going to derive vector identity. Previous lecture we have already seen how to derive some of the vector identities. Today we are going to go for again few more examples how to derive the vector identities. Yes students, we will continue our from previous lecture. We just see today how the next identity we are going to simplify. So already we have discussed first vector identity, second vector identity, then we already discussed vector identity 3. So very easily you can simplify this problem students. So notes I am going to post in this video lecture. Please, in the description box you can see that these derivations are uploaded in the video. Just go to the description students, all these videos notes you're going to get it very easily. So today's lecture we see vector identity 4. Yes, prove that divergence of phi a bar is equal to phi curl a bar plus gradient phi cross a bar student. So we already discussed what is divergence, curl, how the scalar point function phi is there, vector point function a bar is there. So this is another one very important vector identity 4. You can see they have given just prove that. So LHS must be equal to RHS students. Okay, so now we'll simplify this. So keep your books ready students. We'll simplify this now. So I'm going to start with the proof. Okay, they have told us to prove that, so we are going to start with proof. So I say that let scalar quantity a and vector quantity a bar is equal to a1i plus a2j plus a3k be respectively scalar and vector point function. So now we can see how we are going to derive this. So first I will take psi of a bar. First you simplify this term, then later you can take the divergence, or you can take this card. Okay, so first I will simplify this. Psi a bar is equal to phi a1i plus a2j plus a3k. This always I am going to take in terms of summation. This is sum of all a1i plus a2j plus a3k. I am just write this as very simple psi of a1i. So sum of means ijk. Sum itself says that it is ijk only. Okay, that's a very simple to write down. So now I am going to take LHS and I will prove the RHS students. So I will take the divergence of phi of a bar, which is equal to, yes, please remember the divergence and divergence definition, formula, everything we have discussed in the previous lecture, previous video. That video link I will share you in the description box. You will get it, the link and notes students. So now I will take del dot phi a bar. So that's a simple. Divergence can be written as del. So now please remember the formula for del. It is dou upon dou xi plus dou upon dou yj plus dou upon dou zk. I just take this as summation to make it very simple. Summation dou upon dou xi. Please remember this formula students. This is nothing but dou upon dou xi plus dou upon dou y j plus dou upon dou z. That's it. Okay, so let us substitute that value in this, and del of phi a bar. So you can see this del of phi, I will put it this as summation phi a1 I. Is it clear? Okay, so let us substitute both the values. First I will put del value as summation dou upon dou x I. Then I substitute psi a bar. So this is our the value. So this is the dot product summation phi a1 I. Is it clear, students? So just identify ijk value, that is very important. Just substitute the values in this. You can easily see how ij can be simplified. Okay, so now you can going to go for the next step. I will take summation is common in both the terms, so I will just take out summation outside. So I will take out summation outside. So this is going to give you summation is common. I have taken here, students. This will be written as dou upon dou x phi a1. Please remember here I into I. So whereas I into I is equal to 1, j into j automatically will become 1, k into k is always 1. So therefore, if you simplify this summation dou upon dou x psi a1, you see that first u into v. As you can see, this is u into v. So therefore, just I will simplify this summation phi dou a1 upon dou x plus a1 dou phi upon dou x. This is how we can simplify this easily, students. So next you can see this is equal to summation phi dou a1 upon dou x plus dou phi upon dou x into a1. So this is what you can see as students. Summation I will take it inside the bracket. So this is going to become phi summation dou a1 upon dou x plus summation dou phi upon dou x I into, again here we have a1, therefore I will take this summation a1 I. So this is nothing but our divergent of phi a bar, students. So please remember this. Just I have taken summation inside this bracket, and you can easily see that you can simplify in this way. Okay, here we can see phi is only a scalar point function, but here we can see a1, it is sum of a1. So sum of a1 is means it is nothing but a1 plus a1i plus a2j plus a3k. So therefore I have to take summation for a1i. So now you can see in the second term, which is of the form summation a1 b1 is being written as summation a1i into summation b1i. So this form you can see we are going to use summation a1 b1, which is equal to summation a1i into summation b1i. This is a dot product. So here you can see easily, students. this is a dot product. So using this formula, keeping in mind, we have simplified this a into, this is a1 and this is b1 summation. So now here you can see easily students, thus we can say that divergence of phi a bar is equal to phi. This is going to become now divergence of a bar plus this is going to become gradient of phi into the summation a1I is nothing but a bar. So this is a bar students. So this is a bar. So this is how we can prove this very easily. Next we'll go with immediately students. Yes students, very important vector identity, fifth one. So you can see prove that curl of a phi a bar is equal to 5 curl a bar plus gradient phi into a bar. Okay, so we'll go with the proof immediately students. Very important proof these are. Please practice. Same again, let phi and a bar is equal to scalar and vector function. Please remember this every time. So therefore you first take down phi of a bar, which is equal to phi of a1I plus phi of a2j plus phi of a3. Okay, so a1 a2 a3 is there, but whereas you could take the phi is always common in all this. Okay, so immediately we go with the curve. We have come across students. What is the definition of curve? What is the formula for curve? Everything we'll have discussed in the previous video. You can go through that. So this is a del cross phi a bar, which is equal to I j k. This is going to give you dou upon dou x, dou upon dou y, dou upon dou z. Then a phi a1. So beside I, phi a1 is there, phi a2, and this is phi a3. So now when you simplify this ones, easily you can see you are going to take here again plus minus plus. Determinant formula we already discussed. Please go through that video lecture, how to simplify, what is the formula for determinant, and substitute the values. Immediately I will take it in terms of always the summation. So always I am taking in terms of summation. Let's see that summation is nothing but again ijk only. So this is going to become summation I dou upon dou y phi u phi a3 minus dou upon dou z phi a2. So same this is going to continue for ijk. So every time expansion is not required. So this is going to become equal to. So I'll just simplify this a into b, and this is again a into b. So differentiation of u into v. Please remember I am going to use the rule. Differentiation of u into v. U dv divided by dx plus v du divided by dx. So this formula I will use summation I as it is, no change. Now I will take phi as it is, dou upon dou y a3 plus, so this is u into v, dou phi upon dou y a3 minus phi dou a2 upon dou z plus dou phi upon dou z a2. So both the way I have used this formula and have simplified students. Okay, so now again I am going to take the common things and let us simplify. What you will get, we will see. Okay, so here we see now. Immediately you can look at the problem. So phi is constant, I have taken it outside. Remains the summation of dou a3 upon dou y minus dou a2 upon dou z I plus summation dou phi upon dou y a3 minus dou phi upon dou z a to I. So I means what, students? Again you will get same way z and j and z. Is it clear? So you may get both the way, students. I, j, k, you will get it here. Okay, so now we'll continue with this. Yes, students. Now we can see here that the summation of dou a3 upon dou y minus dou a2 upon dou z I is giving you the determinant. Yes, students. You can see easily you can solve this. Always consider, you can verify this as I, j and k, where you can see dou upon dou x, dou upon dou y, dou upon dou z, a1, a2, a3. Similarly, here we can see as one. So ijk, this will give you the determinant. Here you can see dou upon dou x was we have taken a3 and a2 we have taken the values, but here dou phi upon dou y is there, so therefore the determinant you can easily, you can calculate yourself, friends. Determinant using determinant definition, ijk dou phi upon dou x, dou phi upon dou y, dou phi upon dou z. This is going to become a1, a2 and a3. So easily you can see this, student. This is phi. What is determinant? This, student, determinant will give you del cross a bar. Yes, students, you can see easily this is a reverse way of finding the determinant. Determinant, till now we have done determinant. Taking determinant we have calculated the value. Now they have given the value. From that value we have reversed the process and calculated the determinant, and from that determinant will give you the curl or del cross a bar. That's it, students. So therefore this is plus del phi cross a bar. So thus what is we have calculated? This property, curl of phi a bar is equal to phi curl a bar plus del phi cross a bar. This is the proof, friends. See that, practice this again and again, definitely you will get the answer. Or in the reverse way also you can proceed. So first two steps you have to do it very easily. Last step you know already. You know the last step. Now you can see this is del cross a bar is nothing but determinant. So reverse process also we can do it. Del phi cross a bar is this. So remember the formula and substitute. So this is 1. So please remember this, friends. Even you can do the reverse process, but don't lose the marks. LHS is equal to RHS. So we'll go with immediately the next very important last identity, vector identity, students. This is the 6th vector identity, very important. Prove that divergence of a bar cross b bar is equal to b bar dot curl a bar minus gradient b bar. Yes, friends, now we'll prove this. Very easy this is. Take down the proof. Okay, now here we can see, students, there are two vector point functions. Okay, so let us take let a bar is equal to a1i plus a2j plus a3k, and b bar is equal to b1i plus b2j plus b3, b2 vector point function. Okay, so now you can see we have taken two vector point functions of x, y and z. So now we see, first always simplify this, then you put del. Okay, so let us first see how a bar cross b bar is there. So this will give you I, j, k, a1, A2, A3. First A is there, then we take B, B1, B2, B3. This will give you, student, summation of I. Easily you can see A2, B3 minus A3, B2. This is using determinant. If you want to simplify, you can do it very easily. This is nothing but again plus minus plus I is there, cross multiply, give this row and column, A2 B3 minus A3 B2 minus J, A1 B3 minus A3 B1 plus K, A1 B2 minus A2 B1. This is the meaning that sum of first term means the next is minus j this plus k this. So therefore we always take this as summation I A2 B3 minus A3 B2 only. This is same, students, please remember this, summation is same. Okay, now after calculating A cross B bar, now we'll just see divergence of A bar cross B bar. So we are going to take the del dot A bar cross B bar. Am I right now? So A bar cross B bar already we have discussed. Now we just see what is del. This is summation of dou upon dou x I, which is nothing but dou upon dou x I plus dou upon dou y j plus dou upon dou z. Okay. Please see that summation is the only first part of the sum. This plus dou upon dou yj plus dou upon dou zk is always consider it as summation dou I upon dou z only. So okay, now I'll just substitute, students. We'll just find del, substitute the value of del and substitute the value of A bar cross B bar. So therefore, so what you will get here, students, this is equal to summation dou upon dou x I into summation I E2, only the first term, E2 B3 minus A3 B2. Ij is always considered in this. It is understood that ijk is there in the, whenever you take the summation, ijk is always there. Okay, so I will take the common part, summation is common, so I will take it outside. I into I, in this I into I is going to become 1. Please see here, j into j is going to become 1 and k into k is going to become 1. Therefore, if I take out summation outside, students, only dou upon dou x A2 B3 minus A3 B2. Here we can see this, students, everywhere that is u into v, and here also it is u into v. So if I just simplify, please remember the definition of d u into v divided by dx is u dv dx plus v du dx. So this is a formula from differentiation. We use it for partial differential, students. So I will take summation, I will take this A2 dou upon dou x B3 plus B3 dou upon dou 2 upon dou x. So this is first differentiation I have done, u into v. Same way we are going to go for the minus. This term I am going to take, simplify. This is going to be A3 dou B2 upon dou x minus B2 dou A3 upon dou x. So this is what we get the simplification from this. Okay, so now again expanding this, if you just open this brackets and if you just expand this, so it will be in the form of A2 dou B3 upon dou x plus B3 dou A2 upon dou x minus A3 dou B2 upon dou x minus B2 dou A3 upon dou x. Continue this, students. So this is for only I have already discussed ijk, this is first term. So you can see what is second term and third term. So this will give you a3 dou b1 upon dou y plus b1 dou a3 upon dou y minus a1 dou b3 upon dou y minus b3 dou a1 upon y, then plus a1 dou b2 upon dou z plus b2 dou a1 upon dou z minus a2 dou b1 upon dou z minus b1 dou a2 upon dou z. So only first term I have written, means it is the sum of all this. Next will become all, like a2 is going to become a3, b3 is going to become b1. It is like circle, students. So you can take a1, a2, a3. So first term is a1, means automatically second term is a2, next third term is b3. After a3 it will come to next a1. It is a like cycle. Similarly we have b1, b2 and b3. First term is b1 is there, then can interchange with b2 in the summation, then b2 will become in the next summation b3, and next you can see this is going to become. So you can just see this is the simplification what we have done. We have to focus our attention on the RHS of desired result and accordingly plan for rearranging the terms. Since we have dot product with b bar and a bar, naturally we should have the first term lead by b1 and second term lead by a1 with summation notation. So this is how we are going to simplify. So just now I said that this is going to give you summation of b1 dou a3 upon dou y. I have taken b1 common from the above equation. You can please try this. Dou a2 upon dou z minus summation a1. A1 I have taken outside, I have taken common. So dou b3 upon dou y minus dou b2 upon dou z. You please try this ones yourself. So now this is equal to, okay, so this will give you summation b1I into summation, just take the summation inside this bracket. So this will give you dou a3 upon dou y minus dou a2 upon dou z I minus summation a1 I dot summation b3 dou y minus dou b2 upon dou z I. So I and I dot I will become 1, j dot j will become 1, k dot k will become 1. Already discussed, same thing we are going to get here using summation a1 b1. What I have done here, friends, this is using this formula summation a1 b1. This is a1 and this part is going to become b1. So then I have just calculated the summation a1 b1 is equal to summation a1I dot summation b1j. You have used this formula to simplify. So this is again a1 and this is going to become b1. So this is summation a1 b1 is there. I have converted in this form. So please remember this formula, which is very very useful, so that you can easily calculate it, the values with using summation. So you can see you should be very quick to simplify this using the formula. We get this value, students. So now looking at this equal to summation b1I remains as it is. What is this, students? Can you remember this? Summation, this term will give you I, j, k. I had already told we are going to do the reverse process, dou upon dou x, dou upon dou y, dou upon dou z. This is a1, a2, a3 minus, this is summation a1 I. Similarly here we can see this is a1 a2 a3 is there, here b1 b2 b3 is there, so therefore I'm going to take this determinant ijk dou upon dou x dou upon dou y dou upon dou z b1 b2 b3. Easily you can see, yes students, you can substitute summation b1i. In the beginning only I have given summation b1i is nothing but b bar dot. So what is this determinant? Determinant will give you the reverse process students. It is del cross a bar minus summation a1i students have given in the beginning of the question itself, a bar dot determinant will give you del cross b bar. Thus, yes students, thus you can see very easily we have calculated the divergence of a cross a bar cross b bar, which is equal to b bar dot product curl of a bar minus a bar dot curl b bar. So this is how we have to solve all these three vector identities. Please practice the example again and again. We'll continue next video. I'm going to solve the examples on the vectors related to divergence, curl is there, everything. So please practice all these properties and keep it ready students.